I want to begin with a confession. I have spent the better part of my life doing mathematics, solving equations, building theories, pushing symbols across pages, in the hope that something true would emerge on the other side. And for most of that life I assumed, the way most scientists assume, that I was inventing things, that mathematics was a human construction, a language we built to describe a universe that was, at its core, indifferent to our descriptions. I no longer believe that, and I want to tell you why. Let me take you back to something that happened to me when I was very young. I was perhaps 8 or 9 years old, and I had gotten hold of a book on arithmetic. Not a school book, a real book, the kind that showed you how numbers actually behaved when you stopped being polite to them. And I remember sitting on the floor of my room in England, and I discovered that if you take any number and multiply it by itself repeatedly, strange and beautiful patterns emerge. Patterns that nobody put there, patterns that were waiting. I did not feel like I had created anything that afternoon. I felt with a certainty that has never quite left me, that I had walked into a room that was already furnished. That feeling, that sensation of discovery rather than invention, is not unique to me. It is one of the most commonly reported experiences among mathematicians throughout history, and I think it is telling us something important, something we have been too embarrassed or too scientifically cautious to say out loud. Mathematics is not our invention, it is our discovery. Now, I want to be careful here because this is a claim that requires precision. When I say mathematics is discovered, I am not making a mystical argument. I am not asking you to believe in ghosts or gods or platonic realms floating in some ethereal dimension above the clouds. I am making a much more sober and, I think, more radical point. The structures of mathematics exist independently of human minds, and the evidence for this is hiding in plain sight, so plain that we walk past it every single day without stopping to be astonished. Consider the number pi, the ratio of a circle's circumference to its diameter. It is approximately 3.14159, and then the digits go on forever without repeating, without pattern, without end. No human being chose this number. No committee sat down and decided that circles would behave this way. The ancient Babylonians found pi, the ancient Egyptians approximated it, Archimedes calculated it more precisely, and then centuries later Newton, Leibniz, Euler, they kept finding pi in the most unexpected places, in probability theory, in quantum mechanics, in the behavior of rivers which meander in such a way that their total length divided by their direct distance from source to mouth approaches pi. Nobody put pi there, pi was already there. Or consider the prime numbers, numbers divisible only by 1 and themselves, 2, 3, 5, 7, 11, 13. They seem at first to be scattered randomly across the number line, and yet Bernhard Riemann in 1859 wrote down a hypothesis, now one of the most famous unsolved problems in all of mathematics, that the prime numbers follow a hidden order, a deep music in the structure of arithmetic. Riemann found a connection between the primes and the zeros of a particular function, and those zeros, almost impossibly, appear to mirror the energy levels of certain quantum mechanical systems, physical systems. Riemann had no idea, the physicists had no idea, and yet there the connection was, sitting quietly in the mathematics, waiting for someone to notice. That is not what a human invention looks like. Human inventions do not contain secrets their inventors did not know about. But mathematical structures are full of such secrets, full of corridors that nobody built, leading to rooms nobody expected. Now I know what the skeptics will say. They will say, and it is a fair objection, that mathematics is simply a very sophisticated language, and like all languages it was created by human beings to serve human purposes, and it is true that we chose certain axioms, we chose to reason in certain ways. Euclid chose his 5 postulates, Cantor chose how to think about infinity. These were human decisions, and so the argument goes, everything that followed from those decisions was also human, an elaborate game of chess where we set the rules and then explore the consequences. But here is where I think this argument breaks down. But when mathematicians working from a completely different set of axioms, following a completely different path, arrive at the same structures, what then, when 19th century mathematicians exploring non-Euclidean geometry, purely as an abstract exercise, discovered curved spaces that obeyed consistent rules, and then Einstein, decades later, found that those curved spaces were precisely the geometry of our universe. What do we make of that coincidence? The mathematicians were not trying to describe the universe. They were playing, in the most serious sense of the word. They were exploring a landscape, and the landscape turned out to be real. This is what Eugene Wigner called, in a famous 1960 essay, the unreasonable effectiveness of mathematics. Wigner was one of the great physicists of the 20th century, a Nobel laureate, and he was genuinely troubled by this question. He wrote that the mathematical structures which are discovered by mathematicians for purely aesthetic reasons, with no thought of application, turn out decades or centuries later to be exactly the structures needed to describe physical reality. And he said quite plainly that this is a mystery we cannot explain, that it is something we must accept as a given, even though we do not understand it. I have thought about Wigner's observation for much of my career, and I want to offer you my own way of thinking about it. Imagine that you are an explorer in the age before maps. You set sail from the coast of Portugal, heading west. You do not know what you will find, and you find a continent. Now, did you invent that continent? Obviously not. You discovered it. The continent was there before you arrived, before any European had ever seen it, before any human being had given it a name. The act of discovery does not create the thing discovered. It only reveals it. I believe mathematics works exactly this way. We set sail with our axioms, with our logic, with our symbols, and we discover continents. The continents were there before we arrived. The fact that we are the first beings, as far as we know, to give names to those continents does not mean we made them. But now we arrive at the deepest question, and I want to sit with this question for a moment, rather than rushing past it, because I think it deserves the full weight of our attention. If mathematics is discovered rather than invented, if these structures exist independently of human minds, then where do they exist? What kind of existence do they have? Plato, 24 centuries ago, gave one answer. He said that mathematical objects exist in a realm of ideal forms, more real than the physical world we inhabit, which is merely a shadow of those forms. It is a beautiful idea, and mathematically inclined people have been quietly Platonists ever since, even those who would be embarrassed to admit it in polite company. Kurt Gödel, the greatest logician of the 20th century, was a committed Platonist. He believed that mathematical intuition was a genuine form of perception, that mathematicians actually perceived mathematical truths the way our eyes perceive light. I am not sure I am willing to go quite as far as Plato or Gödel, but I am sure of this: the question is not a foolish one. It is one of the most serious questions in all of philosophy and science, and the fact that most scientists are too busy with their calculations to ask it does not mean we should leave it unasked. Here is another way to approach it. The physicist Max Tegmark has proposed what he calls the mathematical universe hypothesis. His idea is that physical reality is not merely described by mathematics, it is mathematics, that the universe is a mathematical structure, and we are patterns within that structure. This is a radical proposal, and Tegmark is quite serious about it. On this view, the question of where mathematical objects exist has a very clean answer. They exist everywhere, because everything is mathematical. I find Tegmark's idea fascinating, though I am not fully persuaded by it. It raises its own puzzles, but I think it points in an important direction. It suggests that the boundary we draw between mathematics and physical reality may be much less solid than we imagine, that when we do mathematics we are not building a model of reality. We are touching reality directly with our minds. Let me tell you about something that happened with the electron. In 1928, Paul Dirac was trying to write down a quantum mechanical equation for the electron that was also consistent with special relativity. He was doing pure physics, but the mathematics he was using was demanding something from him. The equation kept producing solutions with negative energy, solutions that seemed physically meaningless, solutions that Dirac initially did not want. And then, rather than throwing those solutions away, Dirac did something extraordinary. He trusted the mathematics. He said, if the equation gives me these solutions, then nature must have a reason for them. And he predicted that there must exist a particle identical to the electron but with opposite charge, the positron, a particle that had never been seen, a particle that nobody was looking for. 4 years later, Carl Anderson found it in a cloud chamber. Tracking cosmic rays, he saw the track of a particle that behaved exactly as the mathematics had demanded. The mathematics knew before the physics did. How do you explain that with the hypothesis that mathematics is merely a human language? Languages do not predict. Languages do not know things. Their speakers do not know. But the mathematics knew about the positron before any human being did. And this is not an isolated example. This happens over and over again in the history of physics. The mathematics runs ahead of the physics. It finds the answer before the question has even been properly asked. Maxwell's equations predicted electromagnetic waves, radio, light, everything before Hertz built his transmitter. General relativity predicted black holes before astronomers had any reason to believe they existed. The mathematics consistently knows more than the physicist does at the moment of writing it down. I have always found this to be the most astonishing fact in all of science, and I have come to believe that it is telling us something fundamental, something about the nature of the universe and our relationship to it. We are, it seems, very peculiar creatures. We are made of atoms. We evolved on a small planet under selection pressures that had nothing to do with understanding the deep structure of space-time or the behavior of particles at energies we cannot even produce in our bodies. We evolved to find food and avoid predators and raise children, and yet when we sit down with pencil and paper and begin to reason carefully about pure abstractions, numbers, shapes, symmetries, we find that those abstractions describe the universe at its deepest levels. We find the universe in our own minds. Why should this be possible? There is no obvious evolutionary reason for it. You do not need to understand quantum field theory to survive on the African savanna. You do not need to know about Riemann surfaces to find water. And yet the human mind, given the right training and the right freedom, can penetrate to the foundations of physical law, can find equations that govern the behavior of particles in conditions that no human being has ever experienced and will never experience. I think the honest answer is that we do not fully understand why this works. It is one of the deepest mysteries of our existence. But I have a suspicion that the reason mathematics describes the universe so perfectly is that the universe is at its root a mathematical structure, and we are part of it. Our minds did not arrive from outside to model the universe. Our minds grew out of the universe. We are the universe becoming aware of its own mathematics. And if that is true, if mathematics is the language the universe uses to know itself, then when we do mathematics, we are not inventing something new. We are remembering something very old. We are finding in the structures of our own thought, the structures that were there at the beginning. Let me close with something personal. I have spent my life surrounded by some of the most brilliant mathematical minds in history. I knew Richard Feynman. I worked alongside Hans Bethe and Niels Bohr and many others whose names you will find in any history of 20th century physics, and I can tell you that, almost without exception, the experience they described when they were doing their best work was not the experience of building. It was the experience of stumbling into a room that was already there and seeing for the first time what was in it. Feynman once told me that when he was deep in a calculation, there were moments where the mathematics seemed to be guiding him, where it would not allow him to go in the wrong direction, where it resisted him when he made an error and opened up when he found the right path. He was not a mystical man. He was deeply skeptical of anything that smelled like mysticism. But he described this experience without embarrassment because it was simply what happened. The mathematics had its own will. I am an old man now, and I have learned to be suspicious of certainty. I do not claim to know with certainty that mathematics was discovered rather than invented. I hold this view as a conviction rather than a proof, which is perhaps appropriate since the question sits on the boundary between mathematics and philosophy, where proofs are rare. But I hold it strongly, and I hold it because of what I have seen, because of what I have witnessed in a lifetime of watching human minds encounter mathematical reality and come back changed by it, come back with truth they did not bring with them when they left. We did not invent mathematics, we found it, and we are still finding it. And I genuinely believe that there is far more left to find than we have yet imagined. The territory is larger than all the maps we have drawn. And whatever that territory is, wherever it exists, it was there long before we arrived with our pencils and our curiosity and our entirely unreasonable ability to understand it. And that to me is the most extraordinary thing about being human. Not that we are clever, not that we built cities and wrote symphonies, but that we are the kind of creature that can sit quietly in a room and find inside our own minds the architecture of the cosmos. Thank you.